Welcome back, Algebra. So we just finished the OR video. We are now going to do compound inequalities with the AND variation. And again, we are still expressing our emotions appropriately, being that this is the first time and we know it's frustrating, but we're going to try anyway and do our best to learn. In the problem that is typed out, you're going to notice that this is an AND compound inequality. And it is different than the format for those OR inequalities. Take a moment and write on your paper what you notice that is different in the way that it looks, the way that is formatted. When you are done with that, you are then going to try to find the solution of what x values can be to make this compound inequality true. The hint here is to break this into two inequalities. So please pause your video, write what you notice that is different, and try to solve for the value of x. Hopefully you can... Sorry about that. As you can see, the solution is broken into two different inequalities. We have that negative 12 is less than or equal to 7x plus 9. And they took this and solved it on its own down there. The second inequality that it was broken into is the 7x plus 9 is less than 16. And they took this inequality and solved it over here. By breaking it up into the two inequalities, it is a little easier to see how to isolate x and the inverse operations needed to get there. Now that we have the two solutions for what the x values can be, we need to remember to actually graph them. So this first one says that negative 3 is less than or equal to x. And again, we need to remember that x is greater than or equal to negative 3 because we can write that or read that from right to left. So I'm going to go ahead and graph negative 3 on the number line. And that greater than or equal to symbol for x is a filled in circle where all the values of x can be greater than or equal to that negative 3. For that second inequality, we see that x is less than 1. And I'm going to go ahead and graph that solution as well. I'm going to label that as 1. We know that 0 is there. Because x is less than 1, we're going to have that be an open circle. It does not include 1, which is why it's an open circle. And x can be the value of anything less than 1. Our solution then takes both of these graphs and puts them together on the same number line. So what that means then is if we have negative 3, that is included, we're going to go ahead and fill in that circle. And we have 1 that is not included, so that's the open circle. The part that is in common for both is all of the values in between. So when we take those two graphs and combine them, that shows us our one solution for what x values can be. Now that you have tried on your own and see how it can be modeled, this is a you try slide. So again, you're going to take this compound inequality, break it up into two different inequalities to solve for what the value of x can be. Then take your solutions to those values and graph them onto one number line to get your AND solution. I'm so proud of you for continually trying, even though it might feel frustrating. Your trying and your effort does volumes for your learning. I am very proud of you. Again, as you are looking at the solutions, do not erase anything on your paper. Simply just cross it out lightly and write how it should be solved. You can note where your mistakes happened. Now that we have both inequalities solved, we're going to graph them on the same number line. So our first solution says that x is greater than or equal to 2. So we're going to go ahead and put 2 on the number line. And that greater than or equal to symbol means that we have the closed circle. Perfect. We know that it's everything that's greater than or equal to 2. Our second solution says that x is less than or equal to 4. Again, because we have that less than or equal to symbol, we're going to go ahead and put a closed circle above 4. And x is less than or equal to that, so it's going to go in this direction. When we combine these two solutions together, these are the only quantities that x can be that will make the above compound and inequality actually true. So our very last assignment in our notes for these two videos is to sum it all up. We have learned about the or compound inequalities, and we have learned about the and compound inequalities. On your paper, go ahead and write in your own words how or and compound inequalities are the same, as well as how they are different. Please note that these need to be in your own words. I do not want to see the exact chart that's on this slide. This is just for you to give you an idea of the summation of both the videos together. Bring any questions that you may have to a Zoom meeting later this week or to in class, depending on our weather. Have a fantastic day.